Welcome to our series of short educational videos about important concept of building performance. This video shows an overview of heat transfer modes that control heat transfer into buildings. This slide discusses the flow of sensible heat. Sensible heat refers to the transfer of heat in the presence of a temperature differential between warm and colder objects. There is another form of heat which is important for buildings, and this is latent heat. Latent heat transfer occurs in conjunction with the so-called phase change. And here phases are defined as solid, liquid, and gaseous. Since we are concerned about building performance, we limit the use of latent heat and related heat transfer to water. Here, phase change of water from liquid to vapor is evaporation, and from vapor to liquid is condensation. Evaporation consumes significant amount of energy, while condensation releases significant amount of energy. In this video, we are focusing on the transfer of sensible heat. The sensible heat balance of a building indicates the main heat flow processes in the building. An equilibrium of thermal conditions, or what we also call a steady state, is attained when the sum of the incoming and outgoing energy is zero. In our illustrated case, we have the following heat transfer modes. Heat flowing into the building from the exterior environment. Heat generated inside the building by equipment, lighting, and occupants. We refer to this as internal loads. Heat removed from the inside space and rejected to the outside environment by the air conditioning unit. This means that the air conditioning unit must remove heat that enters the indoor spaces from the outside plus the internal loads, and they have to be removed from the indoor spaces. The capacity of the air conditioning unit must be high enough to remove the total heat load so that the indoor spaces can be maintained at a comfortable temperature level. In this slide, we identify the three heat transfer modes that contribute to adding heat to the buildings. And these three modes are conductive heat transfer, and we call this A, and convective heat transfer, we refer to this here as B, and radiative heat transfer, which is C here. And we'll be using these identifiers A, B, and C in our next slide. Let's identify the locations in the building where these three heat transfer modes are active. First, we define the building with a conditioned indoor space, an unconditioned attic, the building envelope, and internal heat loads. The building is in a hot and humid climate, and heat transfer only occurs from the outside to the inside. First, we have conductive heat transfer, which is indicated here as A, and this occurs through the building envelope and between the unconditioned attic and the conditioned indoor space. The rate at which heat is entering the building and the conditioned space is controlled by the level of insulation and other barriers to solar heat gain. Now we have convective heat transfer, which is identified here as B in the figure, and this occurs as warmer exterior air enters the building through intentional and unintentional openings in the envelope, and from the unconditioned attic into the conditioned indoor space. Convective heat transfer also occurs when heat is generated by internal loads. Radiant heat transfer is identified as C in this figure. Radiative heat from the sun strikes the outside of the building envelope, heating walls and the roof. Radiant heat also enters directly into the indoor space through windows, thereby heating indoor surfaces. Indoor surfaces, which are heated from the conductive and convective heat transfer, are causing radiant heat transfer inside the building. It is important to keep in mind that all three modes of heat transfer are occurring simultaneously, where they have certain interactions among each other. The sum of all heat transfer modes determines the overall transfer of heat into the building. This concludes our overview of important heat transfer modes that occur in buildings. We now come to our self-learning assessment. Let's see how much you remember from our discussion. The self-assessment is an important step in the learning process. You can either contemplate or answer the questions yourself, or you can discuss the questions with friends or colleagues. It is proven that the best way to learn a topic is to explain it to somebody else. You see two self-learning assessment questions below. Please try to answer them. You might want to review portions of this video. Thanks for trying. What are the three modes of sensible heat transfer that add heat to indoor spaces? 2. Visualize where the three modes of thermal transfer are acting on the building exterior and inside the building. This concludes our video. Thank you for your interest. Please join us again for one of our other videos about important concept of building performance.